Hi viewers, here is another wonderful SAT question. Here we are asked the area of the shaded region in this diagram. The combination we have here, if you look closely, is a circle, which is obvious, and then we have a square. So how do we get this shaded part? Knowing well that the part we are to find is even outside of the whole circle. So let's do the brainstorming. If you take a close look at this diagram, you will agree with me that the shaded area or the shaded portion is actually a part of the square itself. So if I bring this out, it's more or less as if we have a square marked out by this area of a what? Circle, or by this circumference or an arc from the circle. Then we have the part where we are asked to calculate. So you agree that this shaded area, we can actually obtain it by finding the whole area of the circle, that's the space within this square, the area of the square. Then we remove this part from the square. And this part, if you observe closely, is what we call a quadrant. A quadrant is simply a portion or an area of a circle bounded by two radii, or say the portion of a circle when you divide a circle into 4 parts. So each part here is what we call a quadrant. So take a closer look. The part here is more or less like this. So from that, we can say as solution that the shaded area is the same as the area of a square minus the area of a quadrant. We know that the area of a square is simply the product of the sides of a square. So that means the shaded area we are looking for, area of a square, if we deduce it by L, the product of the side is the area of the square, minus the area of a quadrant. If you look at this, I just said that a quadrant is 1/4 of the entire area of a what? Circle. That means we can write that as area of a circle is pi r squared, all divided by 4. That will be the formula for the area of a quadrant. So here, the area of the square, given that the side is exactly the same as the radius of this circle, which is 4 raised to the power of 2, minus, in this case, pi is not given, because if you look at the options given, the answers are given in terms of pi. So we leave pi the way it is, and the radius of the circle, which is the distance from the center to any part of the circumference, is 4. So we have 4 raised to the power of 2, all divided by 4. So the square of 4 here gives 16, minus pi multiplied by the square of 4, say 4 times 4, all divided by 4. So we divide 4 out, and the final result, which serves as the shaded area in this diagram, will now be 16 minus 4 times pi in unit squared. That's our final answer, which is option C. I hope you find this useful. See you on the next one.